Today we're going to be looking at lesson 3.2 functions. Your vocabulary words are function and function notation. So we have a key concept to start off with. This key concept is known as the vertical line test. It's a function if for the vertical line test, when you draw a line straight down, it goes through the graph only once. Where over here, it's not a function because if I draw a vertical line, it'll go through the graph more than once. So the idea is for every input, we have one and only one output, meaning the values we put into our function, we only get one number that comes out of it. So let's take a look at the first example. So example 1, identify functions. So determine whether each relation is a function and explain. So if we take a look at the first one, we have the domain of -4, -2, 2, and 5, and we have a range of -1, 3, and 6. So you notice for every input, our domains are our input. They go to one and only one output. You'll notice here that the -2 goes to 3 and 2 also goes to 3. That's okay because our input is going to only one output. So this is going to be a function. This is a function because the input go or get mapped to only one output. Let's take a look at the second one. So our domain for the second one, we have 2, 6, 8, and 2. So I notice that I have 2 twice. I have it once and I have it twice. So that's okay if they go to the same output, the same range value. If they don't, then we're not going to have a function. And what do you know? One goes to 3 and one goes to -3. So not a function, not a function. Because the input two goes to both 3 and -3. Let's take a look at our next one. Our next one we have 2, 4, 8, and 4. So again, we have the 4 doubling up. So we have a 4 here and we have a 4 here. If they go to the same output, then we're fine. But you'll notice one goes to a 7 and one goes to a 13. 13 is not 7, so not a function. Because the input 4 goes to or gets mapped to 7 and 13. Basically, we don't know when it goes to 7 and when it goes to 13. So that's why it fails. Let's take a look at number 2. So 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jumps each teams are as followed. So team 1, their best jump was 20.6 and so on. So we want to start off with making a table. So let's make a table. So we're going to have our team numbers as our domain or input. and then our range or our output is going to be the best jump. So this is our feet. So we'll put feet in parentheses so we know the measurement. So we have team 1, team 2, team 3, team 4, and team 5. So team 1's best jump was 20.6. Team 2's best jump was 21.5. Team 3's best jump was 20.9. Team 4's was 19.4. And Team 5's was 20.2. So now let's come up with the domain. So just list it off. And the range for this problem. So the domain, as we said, is the team numbers. So that'd be 1, 2, 3, 4, and 5. The range is all their jumps, their best jumps in feet. If we have any of them repeating, we don't put the repeaters in there. So we have 20.6, 21.5, 20.9, 19.4, and 20.2. So that would be our range. Now looking at this, do we have any repeaters of our domain or our input? And we don't, because we have 1, 2, 3, 4, 5. Each one of our input values is different. So this is going to be a function. For each element in the domain, there is only one element in the range. So we started off with trying to understand the data a little better, so that's why we made the table right here. And then from there, we listed off all of our domain values and all of our range values, and we saw that for each of our domain values, they only went to one of our range values. Example 3, equations as functions. So we want to determine whether 6x plus 2y equals 14 is a function. So if we look at this, and using those ideas that we came up with at the beginning, if we do the vertical line test, so if I start drawing lines on this, I'll notice that my line only passes through the given line once. So because it only passes through it once, this is going to be a function. So this is a function. Because 6x plus 2y equals 14 passes the vertical line test. Meaning that it only goes through the given graph line once. Let's shift it up a little bit as we look at example 4. So example 4 says find the function values. So they give us this expression right here, or this equation for fx. So the function of x equals negative 2x plus 9. Find each value. So what I'm going to do is I'm going to look at what they tell me. They say f of 4 instead of x. Now we're going to put 4 in there, and we're going to add 3 to it. So I'm going to take this equation, I'm going to put 4 in the spot of x. So that gives me negative 2 times 4 plus 9, because that's what f of x equals. Then it says take that and add 3 to it, plus 3. So deal with what's inside the brackets first. So negative 2 times 4 is negative 8 plus 9. And then we'll add 3 to that idea. Negative 8 plus 9 is 1. 1 plus 3 is 4. Let's take a look at the second one. The second one says, okay, instead of x, you're going to put a 5 in there. And then you're going to subtract from it that same function, but instead of 5, you're going to put 1 in it this time. So negative 2 times 5 plus 9 minus, again, use the same function, negative 2 times 1, because now it's 1, plus 9. So negative 2 times 5 is negative 10. Negative 2 times 1 is negative 2, plus 9. Add what's inside each of the brackets. So negative 10 plus 9 is now negative 1. Negative 2 plus 9 is 7. 1 minus 7 more is negative 8. So let's keep going with this idea. So we want to evaluate this function right here. So I have 3 different things to evaluate it with. The first one, I'm going to put a 2 in the spot of x. The second one, I'm going to put a 4 first time and a 1 the second time. And then the third time, I'm going to put a 5 in there and I'm going to subtract 7 from it, just like I did in the first part of example 4. So let's take a look at example 5. Let's put the 2 in there. So h of 2 equals negative 6 times 2 squared plus 18 times 2 plus 36. Well, 2 squared is 2 times 2, which is 4. 4 times negative 6 is negative 24. 18 times 2 is 36. And then we just bring down that other 36. Now add these across. Negative 24 plus 36 is 48. This one I'm going to have to take 2 lines because there's a lot to plug in. So I'm going to plug in 4 for the first one, and I'm going to subtract from it 1. So this is going to give me negative 6 times 4 squared plus 18 times 4 plus 36. And all that's going to be subtracted by negative 6 times 1 squared plus 18 times 1 plus 36. So minus. So for the first one, I put 4 in it. For the second one, I put 1 in it. Now I'm going to start working the problems out. So 4 times 4 is 16. 16 times negative 6 is negative 96. 18 times 4 is 72 plus 36. And we're going to subtract from it this second function right here. 1 times 1 is 1. 1 times negative 6 is negative 6. 18 times 1 is 18 plus 36. So add all this up. Negative 96 plus 72 plus 36 gives me 12. Add all this up. Negative 6 plus 18 plus 36 is negative 48. Subtract those two, we get negative 36. Let's take a look at C. So for C, we're going to start off with plugging in 5, and then we're going to subtract 7 from it. So this gives me negative 6 times 5 squared plus 18 times 5 plus 36 minus 7. So go ahead and solve that out on your own and see what you get when you come back. So pause the video and solve it out. All right, so let's check your work and see how you did. So you should have gotten 5 times 5, which is 25. 25 times negative 6 is negative 150. 18 times 5 is 90 plus 36 minus 7. Negative 150 plus 90 plus 36 is negative 24 minus 7 is negative 31. So you should have gotten negative 31 for that function right there. Let's take a look at one more example. So we have example 6. So Mason works at a movie theater after school. The function g of x equals 9.25x represents the amount of money he makes before taxes for each hour he works. Evaluate and interpret the function for the given value. So the first one, we're going to go g of 8 equals 9.25 times 8. So multiply 9.25 times 8, and we get 74. So for 8 hours of work, Mason earns $74. And that's what they mean by this. So go ahead and try the second one. Pause the video, work it out, see what you get. All right, so you should have done g of 14 equals 9.25 times 14. So 9.25 times 14 gives you 129.5. So that means for 14 hours of work, Mason earns $129.50. And then for the last one, 27.5, plug that in. G of 27.5 equals 9.25 times 27.5. So multiply that out, gives you 254.375. But we're dealing with money, so this is going to be 0.38. So for 27.5 hours of work, Mason earns $254.38. sense. So this is dealing with functions using the vertical line test. So go ahead and write a quick summary of what we covered here, and then use these notes to help you answer the practice questions from the book.